This is a 4-room public housing flat in Singapore. It's made up of 3 bedrooms, a living room, 2 toilets, and a kitchen. Since the 1980s, the majority of our homes are actually made up of modular parts like these. Precast technology is what has helped this small country build big. But
using precast technologies, we need large space for the production facilities. We also need large space for the storage of the precast component.
Singapore is one of the smallest countries in the world at just 735 square kilometers. And as of 2019, only 8% of this land is allocated for public housing. But even in this small space, over the years, Singapore's Public Housing Board has ramped up flat supply. And today, there are more than 100 public housing construction projects ongoing at any one time. And the challenges of building homes in land-scarce Singapore means exploring any usable land.
To strike a balance between development needs and conservation is not straightforward.
It requires construction ingenuity.
BTOs are now built very high in the sky, 40+ stories. So before you're able to build up in the sky, okay, you have to deal with whatever that is under the ground first.
And engineering flair.
By pressing the start button, the autonomous tower crane is lifting the modules to its correct position.
If you look at a typical HDB building, apart from the first story, the rest of the story are constructed using precast components.
From the facade to the columns, the walls, aircon ledge, staircase, refuse chute, facade and laundry area, these are all made using precast technology.
HDB has been adopting precast technology since 1980s. Precast technology is a process where building components are precast outside in a controlled factory environment before transporting them to the construction sites for final assembly. Comparing precast method of construction versus cast in situ method, we can achieve about 30% improvement in productivity.
However, precast technology requires a massive amount of space. There are 21 precast plants in Singapore supplying to HDB. This is the latest plant. It's mostly automated and produces walls, toilets, and bomb shelters meant to protect you in wartime emergencies. To overcome the limited space, modular parts are stored on these specially designed racks. But even with all this automation, this plant can only produce precast components for up to 2,500 flat units every year.
Before we do the installation, we normally have a reserve about 4 stories of precast. In Singapore, there's still a limit on the ability of the land for the precast production process. So in other words, our reliance of precast production somehow has to be still in a place where provide land.
An hour's drive away from Singapore is where the remaining pieces of your public housing flats are made.
We are in a precast plant in Senai. This plant occupies a land area of 36 hectares. It is one of the biggest precast plants in Malaysia, approved to supply precast components to HDB projects. What you see on my left-hand side now are the PPVC, what we call the prefabricated, pre-finished volumetric construction. It is like Lego bricks that stack together to form a building. So when we talk about precast component, it's not just 3D components. What you see here are 2D components. They are precast facade loaded onto the trailer, ready to be transported to Singapore. Those facades are the front part of the bedroom. These are parapet along the corridor when you walk. These are the parapet that prevent you from... This is bathroom unit. What you see here are steel reinforcement. As you know, this is the floor slab. So all these toilets are for the upcoming BTOs. They will be used in our construction projects.
Here's how precasting works. In order to precast a kitchen, for example, it requires creating a customized steel mold, which will take 4 to 6 weeks. When the mold is ready, steel reinforcement bars are inserted. This helps to strengthen the component. Then, concrete is poured in. Once completed, the units are stored at the factory until the contractor calls for delivery.
So once the precast component is produced, they will be placed onto the trailer and then it will be transported across the causeway into Singapore. Every day we see around 130 trailers bringing precast component back to Singapore.
Once in Singapore, components like toilets and kitchens will typically make a stop at fit-out yards. Over here, only the final touches like piping and tile installation will be done. What you're looking at is a kitchen for a 5-room public housing flat that has been completed and now ready to be sent to the construction site for installation.
We built our BTOs flats using precast component. They thought that every component go up can take just 10 minutes to finish the work and they just stack on each other. But it is much more complex. In some of the cases, it can take many hours before the component can be properly fixed and joined together.
As you can see, the autonomous tower crane is lifting the modules. Traditionally, this whole hoisting process will be done by the tower crane operator in tandem with people on the ground through walkie-talkie communication. But with the autonomous tower crane, by pressing the start button, we are able to have this module be delivered to the accurate site position in the shortest path possible. So as it approaches the correct location of where the modules should be, the sky adjuster can be used to orientate the position of the module precisely. This is more productive as opposed to the traditional means of using manual rope guidance. Now, post-COVID, we realized that we have to move towards solutions on site whereby we do not rely so much on foreign manpower. We have to build up our construction ecosystem to be a lot more resilient in that way.
This is important because over the past 3 decades, Singapore's resident population has grown by about 41%. Apart from that, there are more singles who want their own homes. This means needing more flats than ever before, which means more manpower and more space. This is Singapore today. Blue represents the existing public housing areas. There are over 1.1 million flats here, catering to nearly 80% of the resident population. And these are the sites where more HDB flats will be built in the future. They are either categorized as brownfields or greenfields.
Brownfields are sites where there were previous developments that have occupied it. And for these sites, this typically involves the demolition of existing structures, both above and below ground.
In land-scarce Singapore, recycling space is inevitable. It could mean turning what used to be a school, field, and even old public housing into new blocks of flats.
For new BTO projects that is built on brownfield, We found interesting challenges like existing piles left behind from the previous project.
So the piles are very solid foundation to support the weight of the building as it goes up.
And we have to then move our house to a new position, and that will require new design consideration, approval, and that again will impact construction period up to 2-3 months. Most of the time we don't remove the old piles because to remove the old piles, it takes time and it takes a lot of money.
Some projects that we will consider more challenging are those that we have to build in close proximity to existing residential buildings or even schools.
We try to make the process of construction in the 3 or 4 years as invisible to our stakeholders. But along the way, we will receive complaints. Examples, when we start building, the next door neighbors start to realize the bin center that is so close to them, and there was a lot of appeals to change the design. Everyone will tell you that I don't want to have a bin center at my backyard. We are not able to slow down construction, but at the same time, we have to take their feedback, redo some of the design with HDB and even with the architect, and this will involve energy and time.
This is where a highly anticipated public housing project, Havelock Hillside, is going to be. It's an example of a public housing development that will be built within an existing estate.
So Havelock Hillside is actually one of our more challenging projects.
All we have for now is an artist's impression of how Havelock Hillside will eventually look like. It will take about 6 years to complete, about 33% longer than the median wait for flats launched then. Apart from having to navigate the existing infrastructure, there's another bigger problem. It's on sloping terrain, which means more time and money will be spent, because structural elements need to be built to hold the soil in place, which then prevents the building from collapsing.
For BTO projects that are built near MRTs and railways, more time is needed upfront because we need to get the regulatory approval from LTA before we can construct. That is because LTA will want to understand how are we constructing, what are the measures we are putting in place, as well as what are the type of instruments that we put in place, because they are concerned on vibration and movements that will affect the MRT tracks. Some sites are really very challenging to build, but that's where the parcels of land are allocated for public housing.
The average time taken for a BTO is 36 months. Some of the contract can go up to 56 months. So you can see that it all depends on the work that is to be done.
But before any of this construction can even happen, there's an important process called land preparation. It typically involves clearing any existing buildings and vegetation that are not conserved, diverting underground services like water pipes and gas pipes, then leveling the ground to the desired height. The underground soil condition will also be investigated to determine its firmness. And this entire process spans between 2 to 2.5 years. Then, the land is ready for construction to take place.
Whether it's a greenfield or brownfield site, land preparation is to make sure that there is no hindrance or encumbrance before we start our building work. Especially for the greenfield site, which are environmentally and ecologically sensitive, that will be more challenging because we need to take extra care. Greenfield sites are largely undeveloped tracts of land. In these sites will be quite a bit of vegetation. And so before we embark, we'll have to carry out environmental impact assessments first.
We are now on the way to a EIA site. EIA stands for Environmental Impact Assessment. They are normally conducted for greenfield sites that are very near to ecologically sensitive areas.
Consultants are actually tagging all the vegetations of conservation status, large trees. So other than vegetations, they will work around this transect to survey all the fauna, so that includes birds, mammals, bats, butterflies, amphibians, reptiles. And sometimes they also need to mount terrestrial camera traps to track animal movements at night to make sure that it's very comprehensive.
We are now at a potential public housing project site that hasn't been announced to the public yet. So, we have to keep mum on where we are.
EIA can take place as early as 5 to 7 years before the launch of BTO flats.
At the end of the assessment, a detailed prediction of the impact on biodiversity will also be included. Relevant agencies such as the National Parks Board and Urban Redevelopment Authority are consulted. Feedback from the public and nature groups will be consolidated too. Then, an Environmental Management and Monitoring Plan, or EMMP, will be developed. It guides contractors on the monitoring and mitigation measures.
So once the EMP has been developed, we will move into the site. We will progressively shepherd wildlife out of the site, and once they have been moved outside, we can commence clearance of the vegetation as well as the felling of the tree.
They will get an ecologist to conduct a check to make sure the trees within the area, there's no active nests. If there are active nests, they will then need to wait out for the birds to fledge, and after that the trees can be removed.
Apart from trying to make every square meter of land count, Singapore has historically relied on land reclamation. About a quarter of the land we see around us today didn't exist in the past. But while that has solved space-constraint problems,
If you build a BTO on reclaimed land, any land that you reclaim is going to have underlying marine clay because you are reclaiming towards the sea. Marine clay is soft, a little sticky. When you're wearing boots and you happen to step into marine clay, you may be able to retrieve your feet, but your boots will basically be stuck in the marine clay.
I would say that because of the marine clay condition, the construction period lengthens for 6 months, and sometimes it can even drag longer to even up to a year.
this is what you can't see. In order to hold up the flats, piles like these are driven underground. They support the foundations of your public housing blocks. Marine clay is soft and unstable, so more piles are needed to secure the weight of the building. And sometimes, depending on the soil condition, they may need to extend deeper.
But land is precious in Singapore, so the engineer has to overcome the engineering problem to make this BTO happen.
Feeding our appetite for space means construction feats that require more money and time, which is why the construction industry is constantly looking for faster ways to build. And that's what this room represents, the potential future of construction in Singapore.
This room that I'm in now is a 3D printed component.
This was printed using the largest 3D concrete printer in Southeast Asia. What would usually take around 4 to 6 weeks to precast only took the printer 13 hours. And together with the installation of the flooring, windows and doors, this room was completed in just 6 days.
The advantage of having 3D printer is that it could come in to help us to address the shortage of labor. When it comes to precast components, the workers are actually needed to help us with the mold fabrication. With 3D printer, we are able to print the component as long as the designs are feasible to be printed. And this actually helps to save time, save labor. So far, we have been printing landscape benches at Bidadari. In fact, this chair that I'm sitting on, it took about 30 minutes to print the whole thing. In time to come, we hope that we could print as many components as possible. But of course, all this takes time. For example, understanding whether the structural integrity of the room is it suitable given Singapore's climate. So these are things that we are still work in progress.
Typically, it takes around 2 to 3 years for the building structure to be completed. Then, there's still painting to be done. And mechanical engineering works, ensuring that every switch connects to the right cable. And after all that,
I am part of the lockout inspection teams who carry out the final round of inspections to ensure that the flat is ready to hand over to homeowners. When we conduct lockout inspection, it is usually at the final stage of the construction process. At this area here, I noticed that there is this hairline cracks. So right now I will take a picture of it and get the contractors to follow up. Typically, we will inspect 12 to 15 units a day. Eventually, when the residents receive their keys from HDB, everything will be in a good condition.
Many people might not know when it comes to building BTOs, the work behind is extremely massive. At the peak, we could have 1,000 workers on site. 14 to 15 tower cranes swinging. A lot of logistics coming in every day. We work day and night, rain and shine. Even 1st of January, we are working.